Hello, it's Professor Jeffreys, and I'm speaking from my classroom at Green River College. In this segment, we're looking at the different structures of the brain. Okay, first start the spinal cord. Spinal cord. Spinal cord is where there's a highway for all your messages going to and from your brain to your various parts of the body. Okay, as I'm walking, I'm sending a message from my brain down my spinal cord to my legs, telling which way it is. I'm moving my arms. I'm sure you heard paraplegic, quadriplegic. Okay, think about back injuries in general are very severe because it interrupts the messages going to different parts of your body. Paraplegic means paralyzed from the waist down. Quadriplegic means paralyzed from the neck down. Okay, and that's so. In other words, you can tell the severity of the break in the back based upon what the person can or cannot do. Okay, and next, we're talk about is the medulla. A lot of your basic life functions are in the medulla. And moving right up, you have the reticular formation. Reticular formation, they're learning new things every day. One is about the size of a pencil, and basically it goes all the way up through here. It connects with the different structures of the brain, and they found that also it deals with levels of attention. For instance, that's why you're able to continue to focus on driving while your kids are fighting in the back seat. Okay, or helps what messages goes to the cerebral cortex from your perceptual area, and there's a whole lot of other focus of attention. Okay, basically they should look at right now, right? So the reticular formation. Moving right up, down to the cerebellum, balance coordinates your different senses with your motor functions. To a certain, they also discovered that in a certain part of it, associative learning, where they took a rabbit and taught it to associate a puff of air with a bell, and then they cut a particular part of that brain out, cerebellum out, and the rat was unable to learn that again. So a lot of your coordinating motor and senses, and basically are in the cerebellum. And moving right up, you have the pituitary gland, which is the master gland, and right next to the pituitary gland is the hypothalamus. Hypothalamus control center for the rest of the brain, and certainly also the body. It's right next to the pituitary gland. Okay, you hear the term yo-yo? If you're on weight loss programs associated with the word called yo-yo. You lose 30 pounds in 30 days. You gain back 20 pounds in the next 2 days. You lose 8 pounds, you gain back 12 pounds. It's called yo-yo. And the reason people yo-yo during diet programs is the hypothalamus does not know that you want to lose weight. Okay, the hypothalamus sees weight loss as starvation. Okay, and that's one of the problems with weight loss programs. In the long run, the hypothalamus always wins. You lose. Basically, the early stage of dieting, people get lean, and that's because the hypothalamus constantly bugging. But then once you move beyond that, and you're successful in resisting those urges, and you start losing the weight, the hypothalamus goes into phase 2, where it lowers your basal metabolism rate, BMR, basal metabolism rate, the number of calories a person burns when resting. So in other words, you stop eating, your weight starts dropping, and the hypothalamus kicks in and says, okay, you're losing too much weight, and you're not eating, so we'll just lower lower the rate at which you're burning calories. Okay, and as a result, that's why even though you don't eat, you oftentimes you see the hypothalamus sees extra weight the way you and I see money in the bank. In other words, how many people out there have too much money in the bank? And the hypothalamus sees the same thing. So you lose weight, the hypothalamus is going to kick in and try to prevent you from losing. So the key to weight loss programs, so in addition to the dieting and regulating your eating, also exercise, jogging, working out a half hour a day. Okay, to keep that basal metabolism up, so you continue to burn off of it. That's why a lot of people go out and lose weight, and they go celebrate and gain it right back when they eat dinner. And that's how hypothalamus controls weight, but it controls other aspects of the nervous system as well. Moving right up, you have the thalamus. The thalamus is like a relay station. All your messages going up your spinal cord, stop at the thalamus before they go to the brain. All your senses except smell okay, stops the thalamus. For instance, back to the example I used in the previous video, you step on a nail, pain comes up right leg, goes up to your spinal cord, top of your spinal cord, it goes to your thalamus. Thalamus is one of the regulators that messes onto your brain. Okay, brain coming up, right leg. Then basically the brain sends a message back to the thalamus saying, tell the eyes to assess damage. So the eyes assess damage, sends a message back. All your senses except smell, where smell goes directly to your brain through what they call olfactory bulbs. But the thalamus, the relay stage for all your messages going to and from your spinal cord to your brain, or particularly prefrontal cortex. Moving up, you have the corpus callosum. Corpus callosum are a series of fibers that connect the two hemispheres of brain, the left brain and the right brain. Okay, a series of fibers, corpus callosum. You see it on this one. You can't really see it on this one. But it connects the fibers to the left and right hand. You've probably heard of split brain patients. These are people who, because of having seizures, have their corpus callosum cut, which limits the seizure to one side of the brain. Okay, those are called split brain patients. And this is where a lot of the research has come from, in terms of left brain doing certain functions, right brain doing certain functions. A lot of that has come from research with your split brain patients. Okay, the corpus callosum. Moving right up, we have the cerebral cortex. The cerebral, that's what makes humans unique to a certain extent. We have a higher level of the cerebral cortex. That's what we're going to look at in the next segment.